Okay, so here's our first lab. This lab introduces some basic concepts in Python. Python's a very popular programming language, and if any of you have taken any programming classes prior to this class in statistical learning, you'll likely have seen some Python already. So that's also a warning to say that this is not a complete exhaustive introduction to the language of Python. There are lots of tutorials out there for Python. We've included a link below for the basic Python tutorial. And we're also going to be using several common packages, pandas and NumPy, and you can find tutorials for those online as well.
And also the text and everything you see on this page is exactly what's in the lab, in the book.
Yes, and as I said, this is the one I downloaded just off the Statistical Learning website. Okay, so we're not going to read all the text here sitting in the lab. We're going to go through just some of the code. You can follow along in more detail by running the labs, as this is the code that you have access to on the website and is the code that's in the book. Okay, so let's start off with some basic objects in Python. So there's, as most languages have different types of objects. For us, we'll be interested in numeric objects, but Python itself is a language that evolved not to do data analysis, but just as a general purpose language in any case. So there are lots of different standard types of objects in Python. Let's just start with a string. And this is an example of calling a function. Almost everything we do in these computations will be calling some kind of function. Here's an example. We'll call the print function. Okay. And this is an example. You can see how the Jupyter notebooks run. There's a little text box of code that is executed, and the output of the code shows up beneath.
And you just pressed return.
I pressed shift return for each cell, yes. And that will run the code and move it down. As in lots of environments, you might have some questions about the functions you're using. There's a help system in Jupyter. You can access help by putting a question mark after the name of the function, and it will give you what's called its doc string. So if you have a function where you're not sure exactly what it does, you can use this question mark, and many functions have very helpful doc strings. Okay, besides strings, there are, of course, numbers. Numbers 3 plus 3 and 5 add up to 8. And surprisingly enough, you can also add other types of objects. Here we can add strings, and when we add strings, it is concatenation. Most of our work will not be adding strings. This is just, the typical hello world introduction to a language. So we've seen numbers, we've seen strings. There are other objects in Python that start to look like things we might use in computing that start to look like a vector. So down here, I've got something that's called a list in Python. It's denoted by these square brackets, and it's the list of the numbers 3, 4, and 5. Okay. And in doing calculations, you'll often want to add 2 of them. So let's make another list, 4, 9, and 7, and let's try adding them. And there's some counterintuitive results here, because this illustrates, in some sense, that Python is not necessarily, doesn't do perhaps the most natural thing you'd think to do with 2 lists of numbers. It concatenates the list instead of adding them element-wise. And that's because there's lots of different types of objects in Python. For data analysis, what we'll really want to use are arrays, that is, representations of numbers in the computer. And when we have 2 vectors, we'd expect, when we add them, the result should be the sum of the vectors. And for that, we're going to use this package NumPy, which is the standard numerical library in Python. Okay, we'll see some aspects of NumPy in this lab, and here's a link to a more exhaustive tutorial, or the quick start with links to a more in-depth tutorial if you need.
So Jonathan, lists can have items of arbitrary different types, right? So that's why you can't just add, right?
That's a great question.
You couldn't add 3 to hello.
Yes. Yeah. So Trevor points out here that here my list had numbers, but actually we could have a string in there as well. And we could have other things as well. We could have even the print is a function. We could add that to the list.
Yeah.
And when we add it, you'll see it concatenates X with this new list Y. So that's lists are just sequences of any arbitrary Python objects. There's another type of sequence we'll see in a minute called a tuple that looks a lot like a list but is slightly different.
Okay.
Anyways, this illustrates that Python has a lot of generic programming functionality that really has nothing to do with numerics, and that's why we use these libraries, NumPy, and for more structured data, we use pandas that use so-called data frames. Okay, so we're going to use this package NumPy for numerical Python. It's our first example of a library that we'll use, and so a library is just some other code that's been added to the language, or is not, let's say, loaded into the program when we start the program. So we have to access it, and that uses this import statement. So in the further labs, we'll see that every lab will start off with many of these type of import statements. This actually is what tells the computer where to find the code that we will use later when we want to run these specific functions. Okay. So once we have NumPy loaded, we can start to make arrays. And so if you look at the syntax, we called the module or the package is called NumPy, and we decided to name it NP. That means when we want to find a function in the NumPy library, we use this notation NP, that's the library NumPy, dot, that refers to something within the NumPy library, and here we're using the function array. And this makes an array with the numbers 3, 4, and 5, as I had for X above, and 4, 9, 7 for Y. Now, when we add these two,
So NP is an abbreviation in that case.
Yes, and we could have called this anything. We could have called it foo.
Yeah.
If we'd called it foo, we'd have to put foo down here. That's our choice. But NP is a standard abbreviation for NumPy in the literature. So now when we add these two arrays, we get more what we expect.
That's a relief.
Yes. This array is the basic type of object for manipulating numbers in Python. This is a one-dimensional array because it's made from a list, just a one-dimensional organization of numbers. There are two-dimensional arrays, three-dimensional arrays, four-dimensional arrays. Matrices are simply two-dimensional arrays with numbers in them. You can have arrays with things that aren't numbers, but we don't have to start with that. Okay, so here's an example of a two-dimensional array. So we give it a list of lists. So if you note, there's two square brackets. The first entry in the list is the list 1, 2. The second is the list 3, 4. And this is going to make a 2x2 array or a 2x2 matrix that we can use, say, for multiplying later. Okay, now given an object in Python, there are, we'll want to know some things about it. So some things we'll want to know is maybe to find some of the entries in the array, and we can do that with this square bracket. We'll see more in indexing later. But objects also have these things called attributes. So it uses the same sort of dot notation to reference something associated with X. So if I wanted to know, the ndim tells us, what the dimension of the array is. It's a two-dimensional array. That shouldn't be surprising. We can also ask what kind of data is represented in the array, and these were integers. If you saw above, we had put in integers. So there are various attributes any Python object has attributes, and you can inspect them by using this sort of reference here. Okay. So let's move on a little bit. So we might, instead of having integers, we might want to use floating points. That's the representation of decimals in the computer. We can do that by adding an argument float when we call an array. And if you note, I checked its d-type. That is what kind of data is collected. Other attributes are its shape. We won't dwell on all the attributes. There are many of them. Okay, so besides attributes, Python objects also have methods. So here's my array. It's just the list 1, 2, 3, and 4. And I'm going to call this method the sum method on X. So what is a method? It's like an attribute in that it's associated to X, but it's a function. We see it's a function because it has these round curly braces. So not surprisingly, when we call the sum method on X, it returns the sum of the values of X. So this should be 10. OK. And well, you can also compute the sum of an array with a function. There's a function called sum in the numpy library. np.sum of x computes the sum. So whether we use a method or a function will often depend on the context, but this is just to know that these are basic things that Python objects have, attributes and methods, and we can call functions on them as well. OK, moving on. So this next example talks about reshaping an array, which we will not, I don't think is worth spending a lot of time on. One thing I want to show in this example is something about how Python uses reference instead of value. So I'm just going to move on a little bit to get to this point. So without having dwelt on all the examples above, we had an original array X, and then we made this new array X reshape. X was an array of length 6, and we made it into a 2 by 3 matrix. So we can just check that down here by plotting that. So it's a 2 by 3 matrix. And what I want to show in this quick example is something kind of important about Python, is that it uses reference instead of value. So this X reshape, it was actually derived from X and actually has the same data as X. So let me just, excuse me while I scroll up one little bit. So here, this X reshape was found by calling the reshape method of X. So it's another array. It's not X. It's something different. It has a different shape. But when we...
So X started off as a one-dimensional array.
Yes, that's right.
With reshape, you made it a two-dimensional array.
That's right. So that was, which is...
With the same numbers, but arranged in a two-dimensional array.
That's right. Oh, I'm sorry. I see I put a dot instead of a comma.
See, even the experts make mistakes.
So this just to show that X, as Trevor had said, is a one-dimensional array of size 6, and X reshape is 2 by 3. One of the pertinent things I want to show in this is I'm going to change one of the entries of X reshape. So I'm going to change here. This notation here, square brackets, is how you access elements in the array, and here I put 0, 0, and that's actually the entry in the first row and first column. For those of you who have programmed in other languages, you might wonder why I didn't put 1, 1 for the first row and the first entry, and that's because, well, Python is a zero-based indexing compared to other languages. And I would say these days, I think zero-based indexing is more common. C-based languages use it, but in any case, 0 is always the first. It can be a bit confusing for those who are used to 1 being the first. But
like it was for me.
Yes. Yeah. Okay, so I'm setting the first entry, the entry of the first row and first column of X reshape to be 5. So we should expect when we look at X reshape again, that's what we'll do in the next line, it's changed to 5, but X will also have changed. So after I've changed the first entry of X reshape, it has a 5 in the first row and first column, but X also has a 5 in its first entry. And that's because both X reshape and X, they refer to the same place in the computer's memory. And when we change the number sitting in that part of the memory for X reshape, we've also changed it for X. And this is just a useful thing when you start to see a language to know whether it uses this reference system or copy. So using this reference system is a way to be more efficient sometimes. So that's just a heads up that I wanted to pass on when talking about arrays. So whenever possible, NumPy will not copy the array, and it will make what is called a new view of the array. So it viewed the same numbers as a 2x3 matrix with X reshape as X viewed them as a vector of length 6. Another important thing that we'll use over and over in the book is we'll generate random numbers. So let's look a little bit, and we'll talk about the best practice way to do that so that our results are reproducible. So the NumPy library has ways to generate random numbers. This will generate some random normal variables. And one of the things that's important in writing something, going through a lab like this, is to have reproducible results. So of course, the numbers in a random number generator will change from time to time. If I rerun this block, the numbers have changed, and that's because they're random. So we want to be able to set a seed for the random number generator. So the best practice way to do that currently is to set a seed as follows. We make a specific random number generator using this default RNG. And what it allows us to do is have reproducible results. And now instead of using the function np.random normal, we use the function rng.normal. And there I said function, it's actually a method here, but these distinctions are kind of fluid. So now we've created two random number generators with the same seed, and they're going to give us exactly the same data. So that will be how we will have reproducible results throughout the lab.